So welcome to the community call on March the 22nd. Let me share my screen here and walk you through the agenda. So today on this call, we have a few great topics. I'm just going to do a little intro about where we are with the release update. And then we have Benjamin, who's going to talk about using Dapr and OpenFunctions. We have Harry and Sichen, who are going to talk about a review of a proposal for multi-name resolution. And then we'll have time for any open discussion and questions as we go. That'll be open forum to anyone who's on the call. So with that, let me just give a little update about where we are. I just thought I'd give a little mention about where we are with the v1.7 release. As always, with all our releases, you'll see that there's a release planning. And I just wanted to point out that we're very close to code freeze coming up tomorrow before we start the end game for the 1.7 release. So if you're listening on this call and the release is just about to come out in the next week, please jump on the release candidates and start trying those out and give us feedback. The more people who try to release candidates, the more confident we feel. So we welcome greatly the community trying those out. And you can follow along in the end game process here inside this issue here, where we go through all the tests and all of the various criteria that it takes to do a release. It gets quite involved now, but you can see this progress goes along here. But most of all, please try out the release candidates. Another thing I just wanted to point out is you'll have seen a tweet that came out today that we updated the Dapr quick starts. The previous quick starts we've turned into tutorials. These are the ones you may be familiar with. These were a lot more step-by-step tutorials. They use multiple APIs. They went through a whole application. And instead now we've introduced these new quick starts here, which focus particularly on certain building blocks. So for example, on service invocation API and the publish and subscribe. And you can go into each one of these and there's a little sample application that they demonstrate. In the case of service invocation, a checkout and an order processor. And you've got each one of the languages you can try it out inside here: Python, JavaScript, .NET, Java, and Go. And you can go through step-by-step instructions. So it just teaches you one particular thing. And so these were a lot more constrained. You'll see now that we have service invocation, we have publish and subscribe. And you'll see that if you actually go to the quick starts repo here, that the code here is being built for the other APIs as well. So please try those out, give us some feedback, and hopefully you'll find them a great learning exercise along with the tutorials that were there already. So with that, I am going to hand over to Benjamin, and he's going to talk to us about using Dapr and OpenFunction. Benjamin, I will stop sharing and it's yours.
Okay. Can you see the screen?
Yes.
Yeah, I can see it. Okay. I'm Benjamin. I'm the maintainer of OpenFunction. I'm happy to be invited to share with Dapr community how OpenFunction is using Dapr. So first of all, a brief introduction to OpenFunction. OpenFunction is actually a cloud-native fast platform. It has three components under the function umbrella. The build component is used to build function source code into container images. Currently, we are using cloud-native build packs to build the function source code. And the other three build tools can be used to build application source code into container images. And I think the most important part is the serving component. We have currently we have sync runtime and async runtime. For the sync runtime, currently we support Knative as the sync runtime, and we are planning to support KDA HTTP in the future as another sync runtime. And we have one of our maintainers is contributing to this project now. I think the most unique and differentiate feature of OpenFunction is async runtime. It's using KDA to scale the function and using Dapr to connect to the backend services. So it's pretty unique, and thanks to Dapr and KDA. And another component is events. It's kind of like Knative eventing, if you are familiar, but it's much simpler and easier to use. And the event path of events is actually using Dapr's PubSub component to connect to various MQs that you can use NAS streaming, Kafka, GCP PubSub, or Azure event path, etc. So this is basically OpenFunction. Then why do we introduce Dapr in a fast product like OpenFunction? Berkeley have a paper about service. Inside service is composed of fast and fast function as a service and backend as a service. So in the yellow service layer, you can see the cloud function is actually a fast, and the others can be considered as a backend as a service. So, does this have anything to do with Dapr? Let's take a look. So usually in a fast platform, the function should support several languages, and usually the function has a requirement to communicate with other backend services such as MQ. So let's suppose you have 5 languages, and you have to connect to 10 MQs. So without Dapr, each language will have to use a different SDKs to connect to different MQs. So it's it's end up with 50 implementations, right? So, but with Dapr, each language only need to talk to with Dapr SDK, and Dapr handle the rest communications. So we only need 5 implementations. So the complexity of fast implementation has been dramatically reduced. So this is why we introduced Dapr in OpenFunction, right? So it's just like introduce another layer in between the fast and the backend service. It's Dapr. Dapr is acting like a unified interface for the backend as a service. So this is why we introduced Dapr. Now we can take a look at how OpenFunction is using Dapr in detail. We have 2 examples here. Okay. The first example is actually we have a function framework Go, and the function context has a method called send. This method take a component, Dapr component name and the payload. And what it does is to send the payload to the component using Dapr SDK like this. If the output is PubSub, it will call publish event. If the component is the output binding, it will call invoke binding request and send the data to the output binding. So this is the first example. And the second example is actually OpenFunction's async runtime is powered by Dapr. We can take a look at the code. It's in the function framework as well. So you can see actually whenever you create a new async runtime, it's actually create a Dapr service here as a handler passing to the runtime. And whenever you register OpenFunction, whenever you call register OpenFunction to register user function here, actually depending on the input type, if it's a Dapr input binding, it will register as a binding invocation handler to the user function. This is the binding invocation handler. In this handler, it's actually set the input data to the function context and call the function wrapper. And when the function is called, it's handle the output here. Let's take a look at the function wrapper. Here you can see it. It just get the binding or topic events of the binding or PubSub component, and here we got the input event, and then call the function. This is the user function, and with the function context and the user data. So this is how async runtime works. We also support pub stop events, similar as the topic event handler here. And this is the function wrapper. So this is how OpenFunction is using Dapr in detail, right? And currently, OpenFunction only support binding and the pub stop, and we are going to support the Dapr state management building blocks as well, because state is important to function, right? And we are also planning to support, have better support of MySQL and PostgreSQL output bindings. People usually have this kind of requirement when they using function to communicate with RDB, right? Next is I have two demos. The first demo is a logging alert. Is a log alerting with async functions. We collect the Kubernetes log and send it to Kafka, and then launch OpenFunction async run function to consume the Kafka logs with Dapr sidecar and trigger async function. What the async function do is to find some error logs, and whenever it finds error logs, it will trigger alert to send to the notification manager, and then notification will be sent to the Slack. So let's take a look at the code. Right, this is the function code here. Let's say it is pretty simple. The logic is whenever you find a 404 error in the WordPress pod in the demo product namespace, whenever the input data match these conditions, this function will construct an alert manager alert and send this alert to call the send to method to the notify component with the alert content. And we can take a look at the function definition YAML here. Here is how the function is defined. Here's the build stuff, how to build the function images. And here is the serving stuff. It's an async runtime. And here, how the function scales is using Kata, and how the function is triggered and also using Kata to watch for the logs topic of this Kafka server, right? So the most important part is the input and output. You can see the input is actually reference binding, Kafka binding. This is the Dapr Kafka binding, right? And the output is called notify, and it's actually is a HTTP binding here, right? So the alert will be sent to this endpoint. Okay. So let's take a look at the. Okay, I have a function here. Okay. You can see that the build is starting. Actually, the build is inspired by Google Cloud Function. It's using cognitive build packs. We have some customization here. I'm still working on it. I'm still building. Oh, yeah, it's actually built. Saving the container images now. Okay. you can see that the function is actually running, right? So let's take a look at the so the function is actually scaling. Currently it has one replica here. If you scale whenever the logs increase, we can trigger a alert here. We have this is the word price site. Let's trigger alert. Let's see if this Slack receive a new alert here. Wait a few minutes. Okay, should come up. Okay, you can see that. This is the alert, 404 alert in this demo project. Yeah, this is the WordPress pod. You can see that the function replica is scaling now, right? So, yeah, increase more replicas here. Yeah, we can stop this demo. This demo is basically done. Okay, we can delete this demo. Another demo is actually this is the second demo. The sync function and the async function communicate with the Dapr component. Whenever a user trigger send a HTTP request to this URL, this is the sync function's address. So it processes the payload and send the processed result to the Kafka server where a Dapr sidecar. And async function is listening on this specific Kafka topic, and whenever there are data arrived, if you consume the data from the Dapr sidecar and trigger async function here. So let's take a look at the code. This is the function definition. It's pretty simple. The same signature context and payload process the print the data received and then send to the target the same method. This is the function definition here. It's the same as the build stuff. And you can see here is the runtime is Canadian. We have the output is a Kafka output binding here. This is how it works, and the async function is defined in this one. Actually, you can see it handle Kafka input, and whenever the input arrives, it just print the message. And this is the Kafka function async functions definition. It's using runtime, async runtime, the scale, the Kata stuff, Kata trigger, and the input is from this topic. This is the Kafka input binding, right? So actually, I already deployed these two functions to save time. You can see here there are two functions here. And if we watch deployment, you can see all these functions are scaled to 0, right? So we can use this, we can send some payload to this function address here. The function will be triggered. You can see it's starting now. The sync function, the Canadian sync function is starting now. It's starting. Yeah, it's running. And the async function is starting. Yeah, it's running. Yes. So basically, this is my demo. Okay. I think I'm done here.
That's fantastic, Benjamin.
Yeah.
I love the way that you've used Dapr for the reducing number of SDKs and also just the integration between functions. Yes.
Yeah. Okay. Stop my sharing. Okay.
So I'd love to hear if does anyone have any questions?
Yeah, hey, this is Yaron. I'll just say that this is really great. I think I really liked both of your demos, but what I really liked about the second one is that you were able to use Dapr in both your sync runtime and your async runtime. So
Yeah.
the async runtime, yeah, the ones that exposes Dapr to users and also has Dapr powering the eventing side is great, but then you also use Dapr on the Knative runtime, where you injected a Dapr sidecar to Knative deployment, I imagine.
Yeah.
And use Dapr to publish to Kafka. Is that right?
Yes. Yes.
Yeah, and that's really cool. It really shows, you know, the architectural power of the sidecar model, and how you can inject Dapr onto Knative and then into the async runtime and use it to communicate between the two. You know, we've seen these kind of use cases happen from pretty much 2020. You know, Dapr is really developer-focused technology. It's aimed at developers directly. You know, it wasn't necessarily aimed at platform builders. But then, you know, we saw Alibaba Cloud take Dapr and write their functions runtime on top of it. And, you know, now seeing OpenFunction also use Dapr to power up its runtime, I think these are really great use cases. And it really shows, you know, the power of Dapr, not just as a developer-facing technology, but also as one that can power up platforms that are built on top of it.
Yes. Yes. We really love Dapr actually.
That's great.
Currently, we only have Go async runtime, and we have community maintainers working on the Node.js and Python runtime now.
That's great. That's awesome.
Is there a place, guys, is there a place where OpenFunction is hosted that you can just use it, or is it deploy it yourself?
It's not hosted yet. It should be deployed by yourself for now. Yeah.
So OpenFunction is a project that spun out of KubeSphere.
Yes, and we are going to actually we are going to donate this project to Self Sandbox. It's been maybe in the April.
Oh, that's great. Yeah, I'll be sure to support it with a non-binding vote.
Thanks.
And out of interest, does OpenFunction, have you done scale tests on this? Have you scaled this platform up?
Yeah, actually the scale is if you are using Kafka, the scale is depending on the Kafka partitions. We have logs to trigger all the partitions. And you have 10 partition, you can trigger 10 replica. We have tests for that.
I see. Yeah. So you scale up, and you can scale up large numbers of functions to not only, well, in your case, in the Kafka one, but you can just host and run several thousand functions on a single Kubernetes cluster. Yes.
Okay. We have not yet tested that much scale. Yeah. I think it's possible. Yeah.
Yes.
I think we need some image speed technology, image caching technology, maybe.
Yes. That's fantastic.
Yeah, also I'll add just one more thing. I think you'll see that you'll get lots of power added with the state management and sent to functions, because if you look at like AWS Lambda today or Google Cloud Run, which is based on open source Knative, these are all stateless functions, right? Or Azure functions or Google Cloud functions. But if you add state to your functions with Dapr, you basically get like these really small actor-like functions that are stateful. And I think they'll just be really powerful for developers to use.
Yes, I think function is stateless, but always there are requirements to state to store something into other backend system. So that's what our Dapr can help.
Yeah, definitely.
Yeah.
All right, that's fantastic. Are there any more questions for anyone? Otherwise, we'll move on.
Hello everyone, this is Feynman. I would like to know if is it possible to write a blog post on Dapr official website to introduce this kind of scenario, the integration for OpenFunction with Dapr.
Oh, yes. So the question is we are always looking for blog posts to post onto the Dapr site. So if you can write a blog post and give us a good description of the scenarios, what about OpenFunctions, how it integrates with Dapr, and then send it to me or send it to one of the other maintainers. Particularly if you send it to me, we will get it reviewed and we can get it posted. So yes, please write a blog post. We would love to see that.
Feynman is the OpenFunctions community manager. Yeah.
Yes. Yeah, and then the blog posts get pretty broad viewing. So yes, we would more than happy to have a blog post if you write it, and we'll help edit it. Just try to make sure that the context is understanding by everyone.
All right, we'll prepare for it.
Okay.
Yep. Great. That's great. Thank you.
Okay, with that then, let me just share my screen here a moment. We are going to next move on to doing a review of a particular issue that's inside the Dapr repo on multi-name resolution proposal. And I'm going to hand over to Harry for this. So, Harry.
Oh, thank you, Mark. Let me share my screen. Hi, everyone. This is Harry Wang from Tencent. Let me share my screen.
We can see your screen.
Oh, great. So this slide is co-created with my colleague C, who is the brain of this project. So if some questions I cannot handle or it will take a little bit longer time, please feel free to reach out offline to these emails so that we can reply to your questions. So this slide is about the issue 4065, which has been on the GitHub for a while. It's about the multi-name resolution proposal. So we request a little bit more time on this call to directly discuss this issue with your guys, and hopefully we can find some consensus on the way forward. So initially, so back to Yaron's questions before this call, we we take some attention on this issue because we need to use names resolution in other functions, but currently in current architecture is a little bit difficult to use it in current implementation. So here we propose a multi-name resolution proposal. It requires some change on the architecture. We will address that later. So firstly, let me provide some background on this issue. In current implementation, the name resolution is initialized through this configuration, but currently we use it as a global configuration, not as a component, although it's been placed on a component folder, but currently we do not use it that way. So it brings some drawbacks under this architecture. For example, we can only use it between Dapr sidecar communications, and we will allow only one name resolution instance for the Dapr sidecars, not between the sidecar and other functions. And currently, it's very difficult to bind with third-party resources, and it's difficult to discover other services. And it's actually not consistent considering it's on the component directory. So this slide compares the current implementation and the implementation we expect. As you can see that currently it's under configuration. It's one of the configuration, and so we hope we can change it as the real component. So it shows it shows the name resolution in west and east traffic communication. For example, if we show 3 logic services here, if any of these service would communicate with other service, it will require a target ID and other parameters from the name resolution. So in order to do that, service A need to send request to name resolution first, and then get the response of the correct target ID and other parameters to talk with other services and Dapr sidecar. But in another scenario, so if we want to enable communication between service to other functions like state pops up and others, it's difficult to use current implementation. So this is what we hope. How to say? This is our proposal to address this problem. We could create a namespace component, a name resolution component here to improve the efficiency between the traffic and the other functions communication. So in this case, all the functions in the Dapr ecosystem can use name resolution. For example, other services like Redis and Kafka would bind external services in this kind of implementation. So overall, it will be a new, it will be a modified architecture like this one. Again, it shows 3 services here, and also a bunch of other functions here. And with a multi name resolution functions placed in the middle, it could benefit west to east traffic or west to other services traffic as well. So on the way forward, we propose this 3-step method. First, we need to freeze current name resolution related modification in order to switch to the new implementation later. We need to keep the compatibility and for just before the new implementation is ready. And now step 2, we need to add some support of name resolutions to all Dapr components and implement a unified general method for name resolution as one of the components, and initialize the same way as other components. Then we can remove the name resolution, the current name resolution from this Dapr sidecars and switch to the new implementation. I guess that's all about this proposal. Thanks.
Hi, this is Arthur. I have a question.
Right.
Can you go back to slide where you show the components using the names resolution? Yeah, that I think is the one before. Yeah, that one.
Mm-hmm.
So you're proposing here that like Redis, MySQL, and Pulsar, for example, would use name resolution to talk to the services. I don't quite understand like that. Does it mean like the Redis installation or the Redis component?
I guess the Redis component.
And what would the Redis component use name resolution for?
One moment. Feel free to jump in if you think it's necessary.
Mark, you might want give him permission to unmute himself.
Yes. Hang on. For Sichen. You might have to help me. Which person is it? Sichen?
Yes.
Yeah, sorry, my mistake. It's a external service. The Redis, for example.
Okay, so Redis service will be able to use name resolution in Dapr.
Right.
So I think what they mean here is for the individual component to be able to discover the endpoint of the actual service. I think that's just my interpretation. I think this use case, like using the multi-name resolution for external services, is the secondary goal. I think the primary goal, Harry, correct me if I'm wrong, is just to support multiple name resolution components for applications for service-to-service invocation, and allow these to be their own standalone components, right? Which is what you've shown on slide 3, I think.
This one?
Yeah, this is the scenario, I guess, where you might have 2 individual deployments where one needs to use name resolution to discover other services within the Kubernetes cluster, and another service also deployed to Kubernetes might want to use the console name resolution component to discover a service that's running in a separate cluster, for example. Is that a valid use case? Is that a good way to think about this?
Yes, that could be another way to go, I guess.
Yeah, no, I'm just I'm laying out the use cases that are opened, that are unlocked really by enabling this architecture. You know, well, we're on in luck, I think, because we have 4 Dapr maintainers on this call. It's me, it's Arthur, Longday, and Mark. And personally, for me, if you go back to slide 3, if you can do that.
Yes. Slide 3 is the important one.
I think this makes a lot of sense.
Yes.
I think the current way in which component like name resolution is a different type of component is wrong. Like I think it should really transition into your proposed implementation. That's my view, and then we can enable it. You know, we can enable multiple name resolution components, and we can do it in a backward compatible way too. So for that use case, you know, making name resolution components their own component types, I definitely think that this is doable, and it's the good thing to do. It's a good thing to do. I'd like to hear Arthur and Longday's and Mark's thoughts on this too.
The one thing that comes in mind when you're supporting multiple name resolution is how do you pick one when you're making the resolution call? Do you broadcast to all of them and get the first one, or do you have a priority where like try one if use the one that has higher priority to resolve for the service? That will be a question like how do you deal with when there's a conflicting resolutions?
Yeah, so actually I was thinking about something totally different, but the fallback mechanism you're describing actually does make sense in its own right. But what I was thinking is to have users explicitly declare on the call itself which name resolution component they're actually, you know, describing. So this could be, you know, a new endpoint which takes in its URL path a name resolution fragment in the URL, or it can be a header, or on gRPC a metadata. Well, we don't actually have gRPC interfaces, so forget about what I just said. So in HTTP, it's either a specialized URL or in header, that the user basically says, hey, I want to target the Kubernetes name resolution. I want to target, or I want to explicitly target the console name resolution component. And if I don't specify anything, then I basically go to the default one, which, for example, on Kubernetes is Kubernetes, and in self-hosted mode, it's MDNS.
Correct. Yeah. It's, for me, it's always been a little strange that the console name resolution was put inside configuration. It was kind of very different from the rest of the components. And given that we spent the time turning name resolution into a component, the proposal on slide 3 makes total sense. And the scenarios you just described. So you can then be very explicit about them, because I don't think it's very straightforward and easy to necessarily describe the console component in configuration today.
I think the decision of which name resolution to use maybe should sit outside the application. In the application, I think, because I would say that the fact that service A or service B is inside or outside the cluster, I think it's a detail, it's a deployment detail. Especially if you're doing local development, they might be actually co-located. But when you deploy, they might be in separate clusters. So I was thinking that of moving that into the configuration. We could say, even have like maybe a new CRD, or make it part of the component itself to say which services are covered by each namespace resolution.
Yeah, that would be very much like the way Istio does it, with a virtual service, sort of, where the decision about which endpoints are related to each service are governed by an external configuration. And so, yeah, I mean, this is another way to do it, just to push it out to external configuration.
Yeah, because I think I like our simplicity of service invocation in the code, to be honest. And like adding a layer to say, okay, now for you to invoke your service, you have to tell us how to discover it in your application. So I think you're gonna reduce some of the value that we got there.
Yeah, no, I agree, but just to be clear, we can still have the regular service invocation that we have today.
Yes.
And add the optional parameter on the call to explicitly target a specific name resolution component. So if you don't specify anything today, you'll just get the default one. And there will always be a default name resolution component. On Kubernetes, it's Kubernetes DNS. And on self-hosted mode, it's multicast DNS. So if you don't specify anything, it'll behave just like it does today. And if you add a specific URL fragment or an HTTP header, then you're able to tell Dapr, hey, I actually want to invoke this particular call for this component.
Yeah, I understand that. I just want to say that this specific idea, I think, would mean like pushing configuration into the code versus keeping outside. I think that's the only thing that I'm debating here. I think I agree with everything else.
Okay, Long Day, do you have any opinions on this? Mark, can you unmute Long?
Yes, I will do this. Hang on.
He needs to be made co-host.
Oh, here we go. Hang on.
Not yet. Okay, Long, now you can unmute.
Oh, could you hear me?
Yes. We can hear you.
Yeah. Yeah, I just think this is a good enhancement for the special case. Maybe not very common, but maybe useful.
Yeah, definitely it'll be useful for people who want to have two separate name resolution components for in cluster and out of cluster. Like that I think is the major use case this is going to unlock.
Yes, I think this is this maybe can deal with the less work processing in the Kubernetes, but maybe the less work processing is not the main concern in our side.
Mm-hmm.
Just think one issue before if someone says a network processing in the KBS and not special class first, this will do the wrong DNS result, and our Dapr set card cannot work. So this will help that case.
Yeah, it will.
Yeah, that's all.
Yeah, so I think Harry, that we're sort of like coming to a conclusion that this is a good way to recompose name resolution components, and I think we can continue the discussion on GitHub, but I think this makes a lot of sense. Yeah, we should have done it from the beginning, really. When we introduced the first ever second name resolution component, which was console, or third actually, after MDNS and Kubernetes.
Great, thanks, much appreciated. So I will stop my sharing.
Yeah, no, and thank you for bringing this up.
Yes, it was a great topic.
Great discussion. Thank you, guys.
Thank you.
So I will share my screen at this point. If I just move ahead on 2 slides here, we have a chance now for any open discussion. If there's any particular topics that anyone would like to bring up outside of this, anything goes. You can ask about another proposal, ask about the timeline for shipping, ask about a particular question that you have. It's open for anything that you feel free to talk about.
I have a question for the broader community, for everyone here. It's my own personal question. Would you like to see Dapr doing something like stateful workflows, going into workflow orchestration? Do you think a workflow building block is something that would be valuable to Dapr? You can write in chat. Because I don't think people can be unmuted.
If you want to.
In the meantime, I think Sichen is asking, should we add context in components API? Yes, we should pass the context for a number of reasons, but yeah.
Yeah, that is an overdue item. I think it's kind of a big work to get it done, but yes, it's overdue.
Yeah.
Okay, so anyone else like to answer Jeroen's question on workflow? If not, there's Discord channels we can have that conversation on. I think there's actually a lot of potential with workflow and Dapr, but it would be nice to see if there were some use cases that people think of. Okay, if no more questions, then I will stop sharing. Thank you for attending this call. Thank you for coming today, and this content will be posted on our YouTube channel.
Thanks, everyone.
Thank you.
Thank
everyone.
you.
Thank you.
Bye-bye.